Doubly linked list. A doubly linked list is a more complex type of linked list which contains a pointer to the next node as well as the pointer to the previous node in the sequence. And also this doubly linked list allows a traversal in both forward as well as in backward directions. When it comes to singly linked list, we can either we can either traverse in a forward direction or in a backward direction, but here in the doubly linked list we can traverse in both the directions, forward as well as in a backward direction. And this has three fields. This is a doubly linked list. It consists of three parts. Each node, if you take, there would be three fields. One is the data field, in which the actual value or information we would store, and the next field indicates the reference, the pointer to the next node in the list, and the previous field indicates the reference to the previous node in the list. This is how each node would look like. Each node will have three fields. First field would hold the address of the previous node in the list, and the middle field is the data field, which would hold the actual value or actual information, and the next field would hold the address of the next node in the list. And this, if this node is the first node's address would be stored under the separate variable which is called start or a head. This is how each node would look like in a doubly linked list. And next is the key properties of doubly linked list. There are three key properties. One is bidirectional traversal. Here in doubly linked list, nodes can be traversed in both forward as well as in backward directions using the next and the previous references. Using next, we can move on to the previous node. Using next, we can move on to the next node, and using previous, we can move on to the previous node. And second property is more memory usage. Each node requires extra memory for storing the previous reference as well. And third key property is complexity. It is slightly more complex than singly linked list due to the need to handle both the next as well as previous references during insertions as well as deletions. These are the three key properties of doubly linked list, and basic operations are insertion and deletion. Also traversal and searching can be performed here, but insertion and deletion are the two basic operations which can be performed in a linked list structure. And this is how the doubly linked list structure would look like, and this is the representation of doubly linked list, and this is the example structure. If you take each node, there are three fields given. If you take each node, there are three fields. One is to store the previous node's address, next is to store actual data, and third one is to store the address of the next field. So each node has three fields here, and totally in this linked list there are four nodes are there, which means four data elements we have stored in the current example. And if you take first node, since there is no previous node to the first node, always first node's previous field would be having start node previous field would be having null always in a doubly linked list. Why? Because there is no previous node for the first node, right? So the previous field of the first node would be having null pointer all the time, and if you check the next field of first node, it is having the address of the next node. Let's check the second node. If you check the previous field, yes, previous field is having the address of the previous node, which is BB, and if you check the next field, yes, it is having the address of the next node, which is AA, and middle field is having the data. And if you check the last node of doubly linked list, always last node's next field would be having null. Why? Because this is the last node, right? There is no other node here. So this next field of the last node would be having the null. Since there is no other node to process, it is null, which means this is the last node of the doubly linked list. So keep this in your mind that always first node's previous field as well as last node's next field would be having null pointer in doubly linked list. This is how the doubly linked list structure would look like. And also if you check, it is traversing in both forward as well as in the backward direction. With the help of the next field, it can move forward. With the help of the previous field, it can move backward. Now, syntax to create a node. There should be three fields, as I discussed before. In doubly linked list, there must be three fields, right? One is previous, next one is data, and third one is next field. So you have to use a keyword struct. This keyword is used to define a new structure type, and the structure name is a node. First field is struct node star previous, which means this struct node star indicates a pointer to another structure of type node, and previous is the name of the pointer. It points to the previous node in the doubly linked list. And the second field is data field. First field is previous field and second field is data field. This int indicates that the field will store an integer value, and this data is the name of the field which holds the actual data or actual value contained in the node. In real application, this could be any type of data, either character or int, float, boolean, it can be anything. And third field is next field. Struct node star indicates, again this indicates a pointer to another structure of type node, and this next is the name of the pointer which points to the next node in the doubly linked list. If the node is the last node, this would definitely, the next field of the last node would be having the null pointer, and this is the actual syntax to create a node in a doubly linked list. It should have three fields. One is previous field, second one is data field, and third one is the next field. Let's discuss the operations, insertion and deletion in different video.